Welcome to part 3, the final part of our heritage talk on barrows, burials and the Bronze Age at Doveridge. If you've missed parts 1 or 2, click the link coming up now. And if you're ready for part 3, sit back and relax. So the story of our urn is really just at the beginning, and now that it was in the hands of our specialists, we can start solving some of its mysteries. And to help us do that, I'll be joined in a moment by Jackie. She's our principal osteologist and cremation expert extraordinaire. She'll discuss the burial rites and practices of the Bronze Age people, and we'll reveal just who or what was inside the urn. Jackie, over to you.
Right, hello. Now, as Emma mentioned up front, some of this could be quite technical in places. It's our everyday language, but hopefully I'll manage to make it clear enough for you to understand. And if you don't, then please do feel free to ask some questions in the Q&A. Now, I'm just going to step back out a little bit to begin with to set the scene in another way, and that's regarding the mortuary rite of cremation. And this will hopefully throw some light on why I was so excited to hear about this particular vessel from Doveridge. Cremation as a way of disposing of the dead in the British Isles has been in use since the Mesolithic period, so we're talking about 8,500 BC. And at times it formed the predominant mortuary rite that was being undertaken, and it was quite common in the mid to later stages of the early Bronze Age, to which the Doveridge example belongs. So we're looking at about 1,950 to 1,680 BC. Cremation burials at this time were commonly made in ceramic vessels, and almost unique to the Bronze Age phase, these vessels were often inverted, as with the case at Doveridge. Now, cremation is quite a complex mortuary rite with potentially many different facets to it. And unlike with the remains of inhumation burials, where you can rapidly see and assess the formation processes that had been undertaken, working with cremated remains is slightly more complicated and involves rather more detailed analysis to come to grips with what might have occurred at each stage of the process. Now, I say this because, as with the Doveridge example, archaeologists are most often looking at the remains of a secondary stage in the cremation rite, the primary one being that of cremation itself. In other words, the process by which the corpse and its accompanying materials are transformed by that life-sustaining but at the same time quite dangerously destructive element of fire from one state, a recognizable corpse, to another, cremated remains. Now, cremation, as with any form of burning, is a process of dehydration and oxidation of the organics components of the body, including those within the bone, leaving the 70% mineral component. It needs sufficient temperature, which is about 600 to 1,000 degrees centigrade. It needs sufficient oxygen, otherwise you get reducing conditions. This is basic chemistry we're talking here. And you also need enough time. The same requirements were needed in the past as required now in modern crematoria. It could be just as efficient in the past under the right circumstances. In other words, it doesn't rain, which can put your pyre out completely, and it tends to take slightly longer because you're using an open pyre, so the heat, rather than be recirculated as it is in a modern crematoria, gets lost as it rises, so it takes slightly longer. But the end product is also the same, as you can see in these images here. You get recognizable skeletal elements. It's white if it's fully oxidized. You can get from charring, which is black, through hues of blue to grey. You've still got some of the organics remaining in there. And the bone shrinks, warps, develops cracks and fissures along the lines of along which it fragments. And sometimes the smaller bones of the hands and the feet can remain whole. But you're left with an altered state, but it's still recognizable. This bone is now portable, divisible and inert. In other words, the bone from any one cremation, if desired or required, could be divided up and deposited in different places and in different ways. It could be stored, or what we might call curated. It could be scattered, as quite often happens with modern cremated remains. Or, as in the case from Doveridge, and actually archaeologically this is the most commonly encountered type of deposit, it can be formally buried in a grave. But each of these actions would be a secondary rite, a different action which the archaeologist or osteoarchaeologist, such as myself, tries to interpret and understand. So when the osteologist is analysing cremated remains, we're trying to answer similar questions to those faced with when we look at unburnt bone from inhumation burials, but we're also looking for greater details of those formation processes. That is, how the material came to look like it does and how it got where we found it. So we're looking for those formation processes operating at different stages in the overall mortuary rite. So the type of things we are looking for: demography, how many people have we got, what age were they, what was their sex, is there any information about pathological lesions, injuries or diseases that the person might have suffered from that affected the bone. But also we're looking for aspects of the pyre technology and the cremation ritual. So how effective was that cremation process? Can we tell anything about how the body lay on the pyre and what else was burnt with it? How were the remains collected at the end of cremation? And what happened to those remains after cremation and collection? The level to which these questions can be answered depend on several criteria, important amongst which are the quantity of bone available for examination, because you might not have everything that was there at the end of cremation, and of great pertinence, in this case from Doveridge, the level of disturbance and associated taphonomic changes. Those are changes that take place once the bone has gone into the ground. Now, cremated bone is very brittle. It can fall apart just by looking at it. It's already fragmented. It has lots of dehydration fissures that are formed during cremation, and it's easily subject to additional fragmentation due to heavy handling, disturbance, and very importantly, the type of soil in which it's buried. Now, these images illustrate the amount of fragmentation which can occur in the ground due to burial conditions. So you can have, where you've got no soil getting into the burial, then the bone can look like it did at the time of deposition. Where you've got some soil getting in, that soil gets into those dehydration fissures. As it gets wet and dry over the years, it can force the bone apart along those dehydration fissures. And then you can get the monstrous thing that we've got here, where the bone gets very, very broken up both by that process, but also if you've got burial in a very acidic soil, where the soil will attack and destroy the mineral component of the bone and cause it to break up even further. Now, obviously, the more bone there is available to examine and the larger the surviving fragments, the easier the job will be, and the less disturbance to the original burial environment, the more we can confidently deduce about that formation process. So, for the osteoarchaeologist, the star prize is complete, undisturbed burial remains into which no soil has infiltrated. Now, this really doesn't happen very often. And this can be either due to disturbance, damaging the vessel and letting the soil in, or where the vessel was buried upright, the lid, which would probably have been organic in most cases, so we're talking about a cloth or a textile or a skin cover, where that has decomposed and the soil has been able to get inside. Occasionally you would get sort of more robust lids going on things, maybe a ceramic vessel placed over the top of it, or a stone, as we've got here, or in one case you could get plugs of clay put in the top, as in this one of the instances you can say here, but that only survived because it had got a stone on the top which stopped the water and washing it away. So it's very rare, actually, to get a completely undisturbed vessel in which you have got no soil. And when it does occur, it's like Christmas and your birthdays have come at once. And this was my birthday present from Doveridge. Now, Amy's talked about the careful lifting of the burial remains from site. And an important factor here was ensuring that none of the contents fell out as she was lifting it. Hence that little plinth of soil that you can see below the vessel rim. Now it's not as easy as it sounds, because this is quite heavy. It can be easily tip over. This is quite difficult. It's quite heavy. You have to be careful when you're lifting it that you don't jiggle the vessel in any way to move the material around that's inside it. So well done to Amy and her colleagues for getting this out so intact and in such good condition. Now, long experience had taught me that in cases such as this, there would be an empty space, a void in that upturned base of the vessel, since vessels were very rarely, if ever, filled to capacity. And since I would have to set the vessel upright to excavate the contents, my first concern was how I was going to ensure that what was inside would not fall down into that void, which would mean I lost some of that detail of the formation process, i.e. how the remains lay in the vessel, which would demonstrate how they'd been placed in the vessel in the first instance. This was where that little hole Amy had inadvertently made in the vessel in excavation came in very useful. Thank you, Amy. As it allowed me to feed in small plastic beads to fill that void. Then I could confidently set the vessel upright and do my micro excavation. By doing this, what I do is remove the contents in a series of 2 centimetre deep blocks or spits, and each spit by quadrant. That way, when I come to analyse the remains, which are kept in their separate spits and quadrants, I would know exactly where each of the bone fragments had come from and how they related to each other. Now, as you might have gathered, I've done this before. So, what was so remarkable about this particular burial? To help illustrate my points, it's useful to see an annotated image captured by a piece of technology I employed to help my investigations in this instance. And this is one of several hundred images taken from a CT scan. That's a computed tomography scan taken of the vessel. Now, basically, this is like doing an X-ray, but in 3D. And what they do is take lots of different images in horizontal and vertical slices through the vessels. And this is just one of those slices. And these remarkable images demonstrate details of the burial formation process, corroborated and enhanced in subsequent excavation that I undertook and analysis of the bone. The distribution of the bone formed 2 distinct packages, which could be seen both in the CT scan and in excavation and osteological analysis. Clear division between the 2 packages supports the impression of each being contained within a flexible bag. This would probably be in a textile, skin or leather or something like that, something organic. Now, over the last few decades, I've found evidence for primary containers of this form associated with early Bronze Age urn burials, both those made in inverted and upright ceramic vessels. However, the Doveridge example has several unusual features, the first of which is the evidence for 2 bags, each containing bone from a different cremation. The bone comprises the remains of 3 individuals, a teenager of about 13 to 17 years of age, possibly female. This is shown as a subadult in the image. A child of about 7 to 12 years of age, shown as a juvenile in the image, and an infant of about 1 to 3 years of age. The remains of the teenager were found in the uppermost package in the image, i.e. that which would have been placed in the vessel first, and included amongst them are fragments of a worked bone knife pommel and some bones of sheep. These were essentially pyre goods. They were materials that were put on the pyre with the deceased when they were cremated. The remains of the child and the infant all lay in the package in the lower part of the image. In other words, they'd been placed in the vessel second. And amongst the human bone were fragments from an elderly dog, probably a pet, and again some more sheep bones. This was probably a food offering of some sort. And again, these are pyre goods. They were things that were placed on the pyre with the deceased when they were cremated. The quantity of bone recovered, and there was nearly 1,800 grams of it, is substantial, particularly given the young age of the individuals. Characteristically, a juvenile might be represented by less than 200 grams of bone in such burials, rather than the 900 grams seen in the Doveridge case. A second observation, and you really might have to bear with me here as it possibly sounds a bit obscure and navel-gazy, but it's actually quite an important and useful observation in my world because it throws light on all the other material that we find that is not this well preserved. The way we usually clean cremated bone and separate it from the intrusive soil matrix is by wet sieving the excavated deposits using a stack of sieves of 10, 5, 2 and 1 millimetre fraction size to recover the bone. We didn't have to do this with the Doveridge case because we didn't have all that soil in there. But usually stone and pea grits are fully removed from the larger sieve fractions, that's the 5 mm and above. But for the smaller residues, it really would be far too time consuming in most cases to extract all the bone. So generally only some of it will be included in the weight of bone that gets recorded. So we never quite get a full picture. However, in the Doveridge case, because the vessel was totally exclusive of extraneous material, so nothing at all from outside had got in once that vessel had been put in the ground, it meant that the full weight of even the smallest bone fractions could be recorded, including, and this is unheard of, the dust fraction. So we're talking about material of less than 2 mm in size, because that is normally lost within the burial environment completely. Now, because I was able to confidently capture these two, usually elusive weights of bone, it helps to illustrate the proportion of the bone originally included in burial deposits, which might be lost to the burial environment in most cases. In this instance, that amounted to about 14% by weight of bone. In other words, I've told you that I had a weight of bone of about 1,800 grams, but by including those two small fractions, that increased it to just over 2,000 grams, which is normally, and that normally those small fractions are inaccessible to us. Now, my third, and for me most intriguing observation, relates to that final layer of material within the Doveridge vessel, which you can see in the image, which comprised a 2 centimetre thick, slightly concave, solid deposit of fine silt and bone dust, a sort of crust. Since the undamaged vessel had ensured no extraneous material could enter, this layer must have existed before the bag of bone was placed in the vessel. It must already have comprised a solid crust. Otherwise, the inversion of the vessel would have led to those fine particles of material filtering back down to the lowest level within the vessel. That's what happens. It's called gravity, I think. The shape of the uppermost surface of this crust does not follow that of the vessel base, indicating that the bag of cremated bone was curated for some time, sat in or on a different shaped surface or container, which itself had a flat or concave base, and it sat there long enough for these small particles to amass in the bottom of the bag and form that crust. Now, we had radiocarbon dating undertaken on bone samples from each of the two packages, and they suggest a time lapse of up to 10 years between the two cremations, that of the teenager and that of the child and the infant, though the gap is more likely to be in the region of 3 years. In other words, the cremated remains of the teenager had been collected and stored in a bag for several years prior to the burial of these remains, together with those of the other two. Although the probability of burial not always following on immediately or shortly after cremation had been mooted previously, this is the first time such unequivocal evidence for such an occurrence has been found. The desirability of cremation raises any number of emotive possibilities, such as a reluctance to part with a loved one. And I know that I've got some of my father's cremated remains in my office at home, or, as might seem likely in the case here, the wish to lay those who were close in life together in death, potentially to enable them to journey together into the afterlife. And once again, I fully intend that some of my father's cremated remains, which I have retained, will go with mine when I die, together actually with quite a number of my previously loved and now cremated pets, I have to say. So it's not such a weird idea. It's quite normal, really, honest. Such intimate details are of the kind that enable archaeology to bring the past alive, to engage so closely with the actions and potentially the thoughts and feelings of our ancestors, gives a handshake through time and creates a real connection passed down through millennia. And it's this type of engagement which gives archaeology its vitality.
Thank you for watching our heritage talk on Barrows, burials and the Bronze Age at Doveridge. If you're not ready for your archaeological journey to end, don't worry, it doesn't have to. Why not dig through some of our other videos on our YouTube channel? Or if you have a question for our experts and want to find out when our next heritage talk goes live, give us a follow on the usual social media channels. And hopefully, we'll see you next time.